just give a few more minutes for everybody to join. So. Okay. First of all, you guys see my announcement, am I right? So one of the announcement is one that we have a TA. So his name is Harsh. So I think I saw announcement about he joining us to be a TA. I asked him to grade some of the home quizzes, homework. I know, and midterm. So I know that you guys just want everything to be done. Unfortunately, we don't have TA, so bear with us. So he's gonna start grading everything. So I did a few parts. He's gonna finish that one. So that's the first announcement. There is a second announcement about that I post the homework second. So it has probably some of the part that I already teach. So you are gonna see that one. We have another homework coming, homework 3. So I'm gonna post it earlier, but the deadline is probably gonna be after, like it's gonna be short. I will post it like quite maybe this week. So you have that, you need to just finish that one too. That's another announcement that I have. Is it clear?
Yes, Professor.
I understand.
Mm-hmm. Yeah, so that's some of the thing. I just respond to every email that I got from you guys. So if you don't see my response, probably I didn't get your email. So that's want to make sure that I respond to every email that I got from you guys. So if you see that there is an email, you send an email and you didn't get the response, I didn't see your email. Just want to make sure about that one. So let me connect my tablet so I can start teaching. And one more thing is something urgent happened, so I cannot join the class at the time tomorrow. I will put a poll to ask which day is gonna work instead. So for tomorrow's, because I cannot make tomorrow. I need a flight to catch, so probably that's one of the issues, unexpected. So we need to figure it out which day works for most of you guys. So, okay. So let's see here. Let me connect and then. Anybody has any question?
That means we don't have class tomorrow, Professor?
No, we don't have a class tomorrow. So because I cannot make it, unfortunately. I can make an announcement for sure. I will make an announcement. Okay, you guys can hear me, am I right?
Yeah.
Okay. Yeah, so I cannot. Okay, why we have echo? How about right now? Probably it's better. Is it better?
So, Professor, we have three homework total in this class.
Yeah, we have 3 homework. I think we have like 8 quizzes and 1 midterm mock final.
Oh, okay. Okay.
So, so if you have any question about the homework second, so you guys can ask me or you can ask the TA too. So that's the first.
Professor,
Hi.
do we have a date for the final?
I think you guys, I didn't have a chance to ask university based on, I don't know, it's June 30th.
Oh, okay.
I
Is
think
there a
June
time?
30th is on Friday. I don't know. Could somebody check the calendar actually, if it's possible for you guys? Probably you guys have a calendar. Could you check? Anybody can check the calendar. You like SDSU calendar. Anybody has a chance to check it out?
Yeah.
So can you share it with us so I can see? Can you share the link?
It doesn't say like for finals, but it says the last day would be 30th.
Yeah, 30th this month.
Yeah, so let's see. 30th actually is a Friday. Can you send the link? Can you send the link? June 30th. Yeah, the last day of the final exam is the last day of class. Yeah, final exam in 30th. So it's written there. Yeah, so yeah, the June 30th, probably it's gonna be exact same time, our time. Like it's gonna be like exact same time, like 5 to 7, probably. Yeah. But that's what we're gonna have our exam. I will send an announcement for that one too.
Okay, thank you.
No,
So, Professor, June 30 or June 29?
what?
So, we are giving final on 30th or 29?
30th. No, the exact same thing. They said that the exam, that the last day is 30th, so we do the exam on 30th.
Okay.
Yeah, we do the exam on 30th, but about earlier, I don't know, because this is the exact same time that exam is gonna be considered. I cannot deal with students that they cannot do it at the time. So that's the time of the class. So
Okay,
probably,
Professor, so same format like midterm, right?
yeah, exact same time like a midterm. I'm just trying to see which time, actually not time, which like how long does it take better, give you more time. So I don't know.
Okay, got it. Thank you.
Okay, let's go and talk about dynamic programming. Let's see. Okay. So you remember we talked about what? What is the last topic we talked about? And then you guys go and trying to solve it. We talk about coin change. We talk about coin changing, and we say, okay, we have a coin changing. What was the problem? We say, okay, there are some concepts. We say CIJ. What are some of the things I mentioned? So some of the important topics that we talk about actually, we talk about, okay, you want to find the numbers, so CIJ, and see which one has the less numbers. So and then they get the coin. So what we say, we talk about 2 questions we have: value of optimal solution, what is the least number of coin we needed, and then exactly how many of each coin needed. And then we talk about CIJ. We said this is going to be the mean number of coins necessary
to pay J unit using only coins D1, D2 to DI. That's some of the things we need to consider. So that's one of the things we consider. And then also we talk about these things. Okay, I consider this one, so we know that's how it works. So let's see. We consider, you remember guys, we talk about, okay, let's talk about how we do this table. Let's do one table and like a pseudo-coin. I'm explaining about how it works. So probably what we talk about the coin change, we say, okay, one of the examples that we are having, we say, okay, n is equal to 3. I have D1 equal to 2, D2 is equal to 4, D3 is equal to 5, and n is equal to 8. That's what we have. So, and then we say, okay, let's consider this table. So it's gonna be I, the number of the coins, and DI, the units of the coins. I have 1, 2, 3 different coins. The coins one is have 2 value 2, the second is value 4, and the value 5. It's okay. What is the J? It's gonna be J, the number of any of them. It's going, if it's 0, this is gonna be 0, 0, 0. That's the rule that we talk about. If it has 1, it is gonna be less than this value. So because we consider this, you remember there is a formulation that we say, okay, these numbers, we say, okay, Cij is what? Is minimum of Ci minus 1 J and 1 plus C I J minus C I. So we consider this one, am I right? We say, okay, this calculation is gonna be, you put everything there, and now we consider this one. Because this value is gonna be J minus C I, 1 is less than this one, it means it's infinity, it doesn't exist. So, and then we go to number 3. 3 to 2, you cancel, sorry, let's go to 2 first. So we have number 2, everything calculates become 1, 1, 1, because this is gonna be infinity, this is gonna be 1, so the minimum is gonna be 1. Let's go to 3, and then we calculate this one is gonna become infinity, 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 because of the number, and then we go to 4, it's gonna become 2, 1, 1, and then we have 5 again, it's gonna become infinity, infinity, infinity. Actually, no, infinity, infinity, the last one, because it's the higher, is equal 5 to 5. This is gonna be number 1, and 6 is gonna be 3 to 2. 7 is gonna be infinity, infinity, and 2. And number 8 is gonna be 4, 2, 2. That's the whole structure of everything. We calculate everything, we just do have everything ready, so it's written. So, okay, I know everything. So I calculate this one. You guys calculate it in a group too, and then you submit it. So, and then let's write it. Let's see how the algorithm works. So I think if I want to write the algorithm, the pseudocode for this algorithm, it says the following. Algorithm first I've input the array of monetary values, which is going to be D1 to N, and a positive integer N. So this is going to be the array that we have all the coins of value 1 to N, and a positive integer N giving the amount that should be paid. That's the amount you want to pay. So going to pay this amount. So it uses a local array C, which we call C the previous time. So C from 1 to N and 0 to N. It means this 1 to N, it means how many, which kind of coin, and this is going to be the number of values. Okay, coin from 1 to 5 coin, these values, that's going to be the consideration. But now let's write the whole array, the whole pseudocode. So how does pseudocode work? So we say coin change dn. So I'm gonna check. Does anybody know what is this d? What is this d? What is this n? So anybody, you guys write a pseudocode for this. It means that I should deduct the quiz grade. So how did you consider? What is D? What is N? So how many are you guys in this class? 24 students. You submit this one as a quiz. How did you don't know what is D and N? So anybody in the class? Okay, at least one person. So like wonder, okay, you guys solved this question. How did you know? Doesn't know what is this? So yes, these area of condomination, and it's the total we are trying to get. Okay, exactly. So this is something I gave you. I said, okay, what I'm gonna tell you, I said, okay, that was the question. I said, okay, I have $100, and I have this kind of coins. I have coin of 2, 5, 7, 9, for example, and 11. I know these numbers is not like real coin, but I say, okay, I have $100, and this is kind of coin. What is the least number of coin I can exchange, and how many of 2, how many of 5, how many of 7? That's the question that we are trying to solve. It means we have D and N, but we need to calculate the other part. First of all, what I'm going to calculate, I'm going to calculate 1. This is the number of n. N means how many coins, how many different kinds of coins do I have? I say, okay, find the length of D, which is going to be the different kind of coins. Okay, find how many number of coins do I have, and then for what? For I from 1 to n, what you are going to do? Okay, C, I and 0 is going to be 0. You remember, we discussed about this thing. We say, okay, what was the definition? When I talk about these things, I said, we observe that if you don't have any number, it means that I don't give you anything. So, okay, I don't give you money. So you cannot use any of these coin because you don't have any money to buy coin, any of this. So it's going to be 0. For I 1 to n, so this ci is going to be 0. That's the first step. But let's go to the next layer. What is the next layer? We have a table to build. We have I and j. It's okay, let's start with I. It's okay, for every I to n, for any coins, what we need to do? We need to have a look at the j, because we need to finish this table. It's okay, for any I, what's going to happen for any j? So for I and for j, from 1 to n, what you are gonna do? So we say if it's gonna 5 and 6. Number 6 says if I is equal to 1 and what? J is less than D1. It means that I have one coin only one coin. And this number is less than di. What does that mean? It means ci and that j is infinity for sure. Why? What does that mean? It means I have one coin. For example, my coin is 20. And then I have my j, any number. So I want to pay like 6. I cannot pay 6 with 20. I cannot get any of these. Why? Because with 6, I cannot pay to get the coin of 20. So if j is less than di, because di is only one number, if this is less than this one, Cij is gonna be infinity because it's impossible to do this one. That's the reason you put it infinity, because you want to get. This is the step 7. And then let's go to another step. 5. Else, if I have only one coin, still I have I equal to 1, but j is not less than di. It means that it's still if that's the case, we say Cij is equal to 1, c plus 1 minus j minus di. No, sorry. Cij minus d1. C1j is equal to 1c C1j minus d1. Still I try just this one doesn't go out of the page. 1 plus C1j minus d1. That's it. So this is number 9. Why? Because I said I have one coin, and then anything I'm gonna get that one plus the previous one, anything this field. So that's gonna be one coin. But there is another option. So if I is equal to 1, that's 2 options. This is gonna be this one, or gonna be if j is less than this one, and if it's not. If I is not equal to 1, any number. But if I is not equal to 1, else if, but j is less than di. It means that still is still less. So that's going to be what's going to happen in 11. He says Cij is going to be equal Ci minus 1 and j. Why? Because we have more coins, so we do have it above, and this one is going to happen. And then other than that, if this is not the case, in the next level, so number 13, if that's the case, what's going to happen? Then if it's not this case, it means I is greater than 1, Cj is less than this one. It's going to be this whole structure of Ci. This is going to be intent inside. Cij is going to be minimum of what? Minimum of this one, I put it here. Minimum of Ci minus 1 and j. 1 plus Cij minus di. That's the whole structure I explained above too. But we just break this one down to write it earlier, step by step. And at the end of the day, when you finish all of these things, what you are gonna do? You're gonna return CNN. Because you calculate step by step, every layers, everything, and then you will end up CNN. Does it make sense? Does it make sense?
I think so.
Okay. Oh, I see. I was sitting, didn't see that there is one person in that. Okay. There is another. Okay. Thank you. One more. Oh. So We talked about the algorithm can be altered to return the entire table, the result. If I solve this one, as I mentioned earlier, this is going to calculate the whole structure of table. So as you remember, we just talked about this one. The cost of this one is 0. There is nothing. The cost of this one is going to be n, this loop, because it's just a loop of 2. One time, n time is going to happen. This actually, this one. This line is the cost is going to be n, because n time you are going to do this one. But the cost of this one, actually one of them is a small n. Let me fix this one. Because i's go to a small n. A small and the big n. The cost of this one, it means this loop, gonna call this loop again. This is gonna be the cost of n multiple big N. And then it's go all the way down. If I wanna write a big theta, I said the runtime of this algorithm is gonna be theta of, because this is gonna be n multiple n plus O of like this one, n. But because this, or theta of n, because this is a summation, it have n here and this one. Because this is gonna be a smaller than this one, we can neglect this one. We can say, okay, the obviously is gonna be this one because you have the entire table. You actually, if you look at, you understand why it's the runtime, because you have a table of n multiplied by capital N. It means you just do calculation of all of them one by one. No worries, I understand, that's okay. So, okay, I have an exercise as the tomorrow's quiz. Then don't come at me and say, oh, you don't mention that's a tomorrow's quiz.
Since we don't have class tomorrow, what time is the quiz gonna be at?
Okay, because it's gonna be part of the, like a class, exact same thing. I'm gonna post it around like 5. I'm gonna post it earlier so you guys can take it 5 to 5:20. Is it actually? How about I just put the quiz for 2 hours of class, whole class? Is it better?
That would be amazing.
Yeah, I give you guys, because we don't have a class, unfortunately. I give you guys 2 hours to solve the quiz. How about that? Okay. Yeah, that's better, because I don't want to take the time of because the class is going to take off the class for the next quiz on Thursday. So let's do tomorrow's. You guys have 2 hours to solve it. Okay, let me write the quiz really clear, and if you guys have any question, you can ask right now. Okay. Can you see that I just calculate the whole table? Does it make sense? I just did the whole, but the question for tomorrow is like modify this algorithm to deal with the situation in which
Can you go on the table? I just want to see it for 1 second.
this is the table.
Okay, thank you.
You're welcome. So modify the algorithm to deal with this situation in which the supply of coins in some denominations is limited. Let, for example, L 1 to N be another input array where Li is gonna be between 0 and infinity. L between 0 and infinity and require that at most Li coin of value Di be used for I from 1 to n. So what does that mean? You're gonna be limited to the situation supply of coins. You remember the previous time we said as many as you want, but here we say it's like gonna be limited. Let's consider L from 1 to n. So it means that be another input. So this is gonna show that at most which kind of coin you can use. For example, L2 shows that now coin number 2, how many of them you can use. So you guys need to, did you guys understand the question?
Can you just go over the second part really quick? Like from let, right there, you see let I,
L, you mean L?
sorry.
Okay, let's see. Okay, let me write it here as an example. I give you N is the money that we have. For example, it says $80, okay? And I have these coins, I say, okay, I have a coin of $1, for example, 2, 5, 8, and 10. That's the coins that I have, okay? That's the D. And then N, small n is gonna be 1, 2, 3, 4, 5. It means I have only 5 different kind of coins. I have another L, it means maximum I can have only 2 coins of $1, 0 coins of 2, 3, 5, and for example, 8. That it means that coins number 1, I have only 2 of them. Coin number 2, I don't have any. And coin number 5, I have 3 of them. Coin number 8, I have 5 of them. And coin number 10, I have 8 of them. It means it's limited. For example, if you want to generate this one, you cannot use as many coins as you want. Does it make sense?
Yeah, I get it now.
Okay, sounds good. Okay, so that was one of the things that we need to solve. Yeah, that's 80. Sorry. If you guys don't have any question, let me write the next question actually. Next, let's write it here. That was the quiz. Let's go back to another problem.
Oh, Professor, it says on the notes, it says tomorrow quiz. Is that
Mhm.
Thursday or is that Wednesday?
It's tomorrow.
I thought we didn't have
Tomorrow
class
is tomorrow.
tomorrow.
What?
I thought we didn't have class tomorrow.
you guys don't have a class. I'm not gonna teach, but you are gonna take a quiz.
Oh, okay. My bad. I didn't know.
Yeah, so it's gonna be, so when tomorrow is tomorrow, I don't know. Let me write it here. Actually, I write this pink one. Okay. Why it doesn't write? Okay, it doesn't matter. I think I was writing this one, so let me see. I remove this article. Okay. Tomorrow is gonna be 32nd. Am I right? June 31st. Yeah, June 31st. Am I right?
Yeah, 21st.
Exam is gonna be 21st. Okay. Let's talk about all of these things. We talk about this one. We talk about dynamic program. As you can see, instead of like calculating one by one, we use this summation. You see, I use what I have from the previous time. I just put it in the table and don't consider calculating it because I already have it in the table. Does it make sense? Okay. There is a really famous problem. So I need another dynamic program problem. Let's go to another dynamic program problem. The problem name is discrete knapsack.
Just a quick question. So the quiz is going to be just on the previous problem you put, right?
That's it. Yes, this is a
Yeah.
quiz.
Okay, perfect. Thanks.
This is the quiz.
Mhm.
I will post it. I will write a question there. So I will post it again. So this is the problem knapsack. So that this is talking about a thief that wanna steal a few things. So okay, we have a thief that wishes to steal an object labeled 1 to n for each I from 1 to n and okay. So the thief wanna steal from n object, and then you will decide which object to steal because which one has more value. So it's okay, from I1 to n, the number of elements that we can steal, Vi is gonna be what? Value of object I, and Wi is gonna be weight of the object. Because he or she wants to carry it, so probably the value is important. Like, okay, what is the value of the things I'm gonna steal? And then the other thing, the weight is important because you cannot carry all of them. So that's the thing. So that's the value. And then the thief knapsack, so that can carry a maximum weight of W only. So what is his goal? His goal is to feel in a way that maximize the total value of the goods sold. So you see, okay, I have this around, I have like the maximum weight that I can carry is this value, so I cannot carry more. So I need to consider which one has the better value to just steal. What not only a steal, while not exceeding the weight. Constraint. Let's write it in a mathematical way. I say, okay, I have a string of objects. I have x from x1 all the way to xn, which is gonna be all the objects, like, because this is number of objects that I do have. So let's see. I say, okay, if because I have n number of elements, it's like xi is gonna be 1 if object I is a stolen. If object I is a stolen, so xi is gonna be 1. Other than that, is gonna be 0. If what? Object I is not a stolen. That shows that if it's a stolen or if it's not a stolen. So, but let's write the goal. What was the goal? So the goal was like, our goal is to what? Determine this xi. Because if I know xi is 1 or 2, I say if I know that if I steal that element or I didn't. So determine a bit, a string of x1 to xn. Actually, this is gonna be like x1 to xn. So that what? As you can maximize summation of what? We're just gonna solve everything. 1 to n xi vi. Why? Because if xi exists, it's a stolen, we just put the value of the object. It's okay. Oh, I stole the object 5 and the value is $10, for example. It's okay, this is gonna be, and then subject to what is the constant? First of all, the summation of all elements that you steal from xi, but divisible to weight is gonna be less than W, less than equal to W. You cannot exceed the weight of the when you want to carry. So this is gonna be the whole overall optimization problem that you need to solve. Does it make sense? Okay. If it makes sense, I'll give you guys 5 minutes to think, how do you gonna solve this problem? Think about it like the previous problem. What is the 2 problem we need to solve? Just write it. Tell me what is the 2 problem we need to solve and how is the best approach you are gonna do? What do you wanna do actually if you wanna do that? Think about it for 5 minutes. At least have it. This is like a dynamic program problem. This is going to be, for example, there is another dynamic programming in final exam. You need to think about this thing. How do you going to approach it? What is the problem? How do you going to solve it? I just give you guys 5 minutes to think about it. Does it make sense? Make sense? Yes, no, anything? Okay. Here is really hard to just see that how many times I should ask one person say yes or no. Okay, sounds good. Okay, let's wait and let's see. You guys have 5 minutes to just solve the problem and let's think about how to solve it. Okay, anybody has any idea? What is the two problem? Okay, let's try the first problem. Anybody has any idea? There are two problems we need to solve. Let's write it. Again, there are two problems. First one, find value of an optimal solution. And second one, find optimal solution. It means which item you are gonna steal and what is the value of that. Find optimal solution itself. It means, what does that mean? It means find a particular, because you find a combination. It's okay, can't steal this item, don't steal the other item. So it means you have a particular bit string, which is going to be the name of x1 to xn. It means this item should be stolen and then the other item shouldn't. So it's x1 to xn that achieves that maximum. Next. Let's clear it up again. So okay, it means first of all, I say okay, this person steals something. What is the benefit? How much he just get it based on this item is stolen. And the second question is okay, this person steal this item. So okay, if that's the case, now which one did this person steal? Did this person steal the item 1 or 2 or 3 or the other? So that's the second problem. So you guys get it, that's why we have two problems. Does it make sense? Okay, sounds good. Okay, let us start to see how we calculate all of these things. We say let I is going to be 1 to n. This is number of the items that you can see. And then j, what is j? This is the weight of each item. The weight of each item can be between 0 and the maximum weight that you can steal from the knapsack that you want to have. So what is going to be v? Now let's define a variable, because again, this is a dynamic program. You want to make a table. You need to have variable. Max ij, it means value that I get for this item if this is the weight of this item. So it's going to be maximum value of object 1 to I whose total weight is less than j. Anything, you find about values that you get from this item, but the weight is going to be less than. So we have two alternatives for. Okay, so Now you guys understand what is Vij. Am I right? Capital V. This is a value. It means in each time step, if I consider, like, for example, V of 1 and 3, what does that mean? Is it find the maximum value of object 1, 2, because I have I, it means only one object. Let me put this one actually 5, so it makes it easier. It means I'm gonna steal 5 items and then J. What does that mean? With the weight of 3. So it means because my cat, like for example, I can carry only weight of 3. You say, okay, what is the maximum value I can get if I steal item 1 to item 5? Then all of these items, the weight is less than 3. Because the maximum weight you can carry is 3. So it means any of these items, if they have them like values less than 3, you can do the summation and you can carry them. Am I right? Does it make sense? Clear? Okay. Let's see. How can I solve this one? I say, okay, let's do something. Because we just want to solve it in dynamic programming way, I say, okay, we have 2 alternatives actually. Let's see. We have 2 alternatives for what? For V, I, or J. Does it make sense? First, we say, okay, if I know anything before, like I calculate, so I say, okay, if I still, let's see, I'm just having a bag, let's say I have a box, I put all of the items there, and I'm moving from one item to another. It means if I move from the beginning of the box to the end of the box, I already know what is the value, maximum value from the previous one. So it means what I can do, I can exclude, do not include object I. If I remove that one, the max value is what? Because it's gonna be V, everything is the same. I just remove I. It means it's gonna be this value. It means every time, so I just have this previous one for the previous one, I can calculate this one. We said, I said, okay, I'm gonna calculate it. I said, okay, I wanna have all the item. I don't want to have the item I minus 1. This is gonna be the result. Or what I can do for the second one, include object I. There's 2 options. Remove object I, say I don't want object I, or include object I. And then what you are gonna do? You're gonna find the maximum value is gonna be what? Vi, because I include I. A second, there's 2 ways. Remove I or have I. If I remove I, this is gonna be the result. If I have I, Vi is a value of the L of I item. Now V is gonna be what? I minus 1, because I already removed one of the items. So, and then what? J is gonna be minus Vi, because now I have the weight of that value, that item I. So I need to get it out of the values. Does it make sense? Is this clear? Okay. For example, oh my gosh, just give me one more. Okay. One more, please. Okay. So let's consider consider, for example, I have 10 items. This makes it more easier. Probably 5. Let's put some names. So just give me 5 items. So I can write it here. At least suggest 5 different items. Okay. Glasses. Only 1 person. Book, pencil. And you guys doesn't have any other suggestions? 2 more. Okay, phone. 1 more. You know that yeah, he's gonna use or she gonna use a knapsack. Computer is a little huge for that. You know that? Okay. I put one of you guys a bottle. Okay, let's consider I have 5 items. My knapsack can, the maximum weight I can carry, the stealing maximum weight is gonna be like 25 pounds. Maybe a little higher. Let's put it like 50. I put 50. I think okay, I can, this is the max I carry. Let's put a weight for each of these items. Consider the glass weight is like 2 pounds, for example. Gonna be a lot, 2 pounds for glasses, but anyhow, like books is gonna be like, it makes it less, it's too much. 25, it's gonna be 5. Pencil, like phone is gonna be like 3. I know it's not realistic, but like anything, it's 8 pounds. Let's consider this one to be 10. Okay, this person can steal 10, the maximum can carry is 10 pounds, and this is the item. I have these items and I have this one. How can I solve this problem? Because I'm gonna get maximum, I wanna have the maximum value. Okay, if you look at these ones, what do you feel? So based on these values, which one you are gonna get? And this weight. Oh, let's consider the values too. Okay, sorry, I forgot something. This is the weight for each of them, small v, and let's a small v. So for example, glasses has the like 20, books is gonna be 10, pencil is gonna be 5, phone is gonna be 300, and water bottle I consider is gonna be 100. So this is the value, and based on the weight and the value, what is the best thing to, how many items are you gonna store and what is the number? What is the number you are gonna get it? So, only 2 or 3 respond. I don't know if you guys are still in the class or not. So last value is 1. Which one? This is 300, this is 100, 1. Okay, I know you write that V multiple W. No, so this is really simple question. It's okay, I have 10. The maximum weight I can carry is 10 pounds. And this is the weight of any item, and this is the value. You want to steal an item that is less than this 10 pounds and it still have a really high value. Which one do you gonna steal? Okay, instead I'm gonna steal the phone. Phone is gonna be 300 value, and the weight is gonna be 3, is less than 10. Is it enough? Did you get the whole? Is it enough or not? Okay, that's the way we solve this problem. I say, okay, let's solve this problem to see how we can do that. So let's steal, I sounds like a steal phone or not a steal phone. Maybe it's better. I know this phone has 300, but maybe the other has a better weight. I don't know. So if I steal phone or not a steal phone. If I don't steal phone, I say, okay, if I don't steal phone, what is gonna be? I'm gonna have a V, find the maximum value. Instead of having 5 elements, because I remove phone, now I have how many elements? I have 1, 2, 3, 4. So now it's gonna be I minus 1. It means V of 4. I have only 4 elements. I already removed phone. And then what is J? Or I can consider all the J. It means I can look at only these 4 elements, 1, 2, 3, 4, and consider all the V and J. And it's okay, I can consider 4 elements and the maximum value I can get. And this is the number. So that's the first thing. Does it make sense? This is the way, because it's like no phone, so I is gonna be minus 1, but J doesn't change because I just don't use anything. So J is gonna stay the same. Does it make sense? Clear?
Yeah, Professor, but can we explain
What?
why we steal phone here?
Why a steal phone? We didn't decide if we a steal phone or not. We are talking about, do we want to steal or not? There is 2 questions. Every item that I have, I'm gonna say, okay, am I gonna steal it or not? Here I said, don't steal it. If I don't steal it, I don't have 5 items anymore. I have only 4 items. And other than that, everything gonna stay the same. Is it clear?
Mhm.
Now let's see. I want to steal the phone. If I steal the phone, I say, okay, find the value for me. As I mentioned, it's okay, V this time, V of like, V was gonna be what? This time I have V of I, which is gonna be what? I already knows that the phone has 300. I say 300, this is the value I can get, plus what? Again, V, this time, still I have 4 items, still glass, book, pencil, and water bottle. I have 4 items, which is gonna be I minus 1 if I write it here. So it's gonna be I minus 1, which is gonna be 4. And this time, I already put the phone inside my knapsack. It means I already carried 3 pounds. It means I don't have 10 pounds anymore. How many of pounds I have? I have only 7 because I already filled something there. So that's the reason we say J minus WI, because this is going to be the weight of the phone. I already deduct that one. It means next time I have 7 pounds only. I don't have a 10 pounds anymore. Does it make sense?
Yeah, thank you.
You're welcome. Now that's the reason I have 2 cases. One case is we say, okay, don't have phone, and the other case, I have phone, but I just consider that value and put it outside. Is it clear?
Got it. Thank you.
Good. So let's go to the now. So okay, if I do this one, I say I calculate without phone and with phone. What can I do if I consider calculating without phone? I'm going to calculate with phone. What should I do? Now I need to say which one is maximum. Is a stealing phone is better or not a stealing? So now the problem is going to convert to what? So we chose the best option. What is the best option? It's going to be V of ij. It's going to be maximum of this one. V of I minus 1, as I mentioned, and j, and vi plus v of I minus 1 and y, j minus wi, the weight of the phone, for example. This is, you find the maximum between these two. Let's move it a little. Let's close this one. Vi plus v of I minus 1, j minus. Is it clear? Okay, let's consider include boundaries. Where this place is going to have a boundary? There is a boundary for this thing. Okay, because we are consider. So okay, let's write it this way. Let me write it like this. So V, I, and J is equal. Let's put it here. Actually, let's move it a little this way. I say, okay, if I is 0, J greater than 0, equal to 0, what does that mean? I don't have any item. There is nothing to steal. If there is nothing to steal, it doesn't matter how big my knapsack is. It's going to be value, is going to be 0. There is nothing I can steal. And if there is no space in my knapsack anymore, so the value is going to be minus infinity. It means it's minus. Don't steal it because you don't have a space. But in the middle, if I is positive and J is positive too, it means you have item and you have some way to fill it. So that's the time we say, okay, maximum of Vi minus 1 oh my gosh, Vi minus 1 and J plus no, Vi plus V of I minus 1 and probably I put this one a little down. This is the second one. Does it make sense? Okay. Let's do an example. Let's do this. Let's fill this table together. This time, let's do it together. Okay. So I do have 5 items again. The weight of this item is going to be 1, 3, 5. 1, 3, 5, 6, 7. And then the value of this is going to be 1, 5, 12, 25, and 30. And what is the maximum weight? It's going to be 10. It means you can carry only 10. Let's make the table. Let's see how to fill the table actually. again, I have I. It means I have elements 1, 2, 3, 4, and 5. That's it. Any of them has a weight, has a value. The weight of the first one is 1, 3, 5, 6, 7, and the value is 1, 5, 12, 25, and 30. And let's put the J. J is gonna be 0 up to 10. 1. Let me see if I can fill them here actually. I think I did it. Okay. So let's calculate them. So, okay. I said again, here go above anything or anyone. If I don't have any elements, J greater than 0. So, and I don't have any element. It means that the first one, if I consider this one, the first one, oh, okay, let's consider the first one, the first observation. It means that I don't have any weight. If J is equal to 0, it means I don't have any weight to put. There's nothing, no empty. It means I cannot carry any of this item. I already don't have any space, any weight that I can carry. So how about when I have only 1? It means the weight is gonna be 1. I can still one item, so I actually. What is the value of this? If I consider this one, the value is going to be 1, 1, 1, 1, 1 again too, if you consider this one. Because the J is going to be 1, which is going to be here. You consider Vi minus 1, the previous one is going to be 0, and this is going to be 1, the value of Y itself. Vi is going to be 1. This value is 0, 2. 1 maximum of this 0 and 1 is going to be 1. And then you calculate, go all the way down to the bottom. So if you calculate, this one is going to be this. The second part is going to be the same thing. You just use the previous value, I minus 1, and calculate this one. This is going to be the case. But let's see. How about this 3, 2? Because 3 is going to be when I is one number, and then you can find the maximum, which is going to be 0, and this one is going to be 3. But how about number here? Anybody consider this number? Can you calculate this? Actually, how do you calculate? Anybody? What is that? Is V of what? This value, I is 2, I and J. I is 2, I is 2, and J is what? J is 3. How do you find that one? This is coming from maximum of V, V1, 3. We say don't consider one of the items. Vi, which is gonna be V number what? I is 2, it's gonna be V2 plus V1, and then consider this one out. So this is number 2. If this V is gonna be 3, it means that what is the maximum was? Was that 10? 10 minus 3 is gonna be 7. So 1, 7. You need to find this one. So this is gonna be V1, 3. So it means that I is 1, J is 3. I is 1, J is 3. This is gonna be 1. And then V2. What is V2? V2 is number 5. It's gonna be maximum. 5 and V1, 7. So this is gonna be 0, 2. So it's gonna be maximum of 1 and 5. This number is gonna be 5.
How
This
did
is
you get 0 for V17?
why?
For V1,
So- Okay, so let's do it again. So we say we have I equal to 2, which is gonna be here. It means I is 2. Am I right? I is 2 and J is 3. It means gonna be V and 2 and 3. The maximum is gonna be V of 1 and J of 3, and then V2, which is gonna be the value, and I minus 1, this is gonna be 1, and then J, okay, sorry, that's a mistake. I made a mistake here. Is this J? What is J? J is 3. 3 minus this, wait, 3 minus 3 is gonna be 0. Which means this is gonna be V of 0. V of 1, 0. This is this one. V of 1, 0 is 0 because there is nothing. There is J is 0. There is nothing. This is the first column, you know. V of 1 and J is 0 is this one. The first one. It's gonna be 0. This is 0. Does it make sense? And now this has become 5.
yeah, I got it because I was confused with the 1-7. No, but now I
Yeah.
got it.
Let's go to something actually really high. I will fill some of these numbers, but let's calculate one more. I will put this on 1, 1. If you keep going, this is gonna be 1, 1, 5, 5, 5, and then it's gonna be 1. This all of them is gonna be 1, 1, 1, 1, 1, 1, 1, and this is gonna be number 6, 6, 6, 6, 6, 6, and number 6. This is gonna be number 1. This is 12. This is 13. 13, 17, 8. So, okay, well, I missed something here actually. Oh my gosh. So this is 1, 6, and then we have another 6 here. Then I have number 12. And then I have number 13. Then I have number 17. Okay, I think I made a mistake. Number 16, 12, 13. I'm sorry. This is 13 too. 13. How can I put this one? Okay. 13, 17, 18, 18. Okay, let's find this one actually. Let's find this number. This one. That's gonna be V of what? I is 5, J is 9. Does it make sense? This is gonna be the maximum of what? Anybody?
Can you just go up and show the equation one more time?
Mm-hmm.
So I can take a picture and I can.
Instead of memorizing, it's easier to say, okay, I have 5 items, like right, 5 items. I think I don't want to consider item 5. If I don't consider item 5, I have 4 items, it's still 9. It is because nothing changed. And if I consider item 5, it means I want item 5. Item 5 has the value of 30. It means I'm going to get the 30 of the value, but do the summation. Now I have only 4 items because 1 item is removed. And now I have 9, but this item that I got, this item 5 already have 7 weight. So it's gonna be 9 minus 7, it's gonna become 2. So now I do have this one. What I want, V of 4, 9. So it means I need to go 4, 9. I think I already don't feel this one. So 4, 9 is 30. This number is 30. So, and this is 32. 30 plus what? V of 4, 2. 4, 2 is already 1. I know it's become, this one is become 31st. So this value is become 31st. That's the reason it's table. You need to calculate that one. That's a dynamic program because you keep it. Next time, instead of calculating V42 from the scratch, you already have it in the table and you fill it. Does it make sense?
So above that, you got 30 off the top of your head. How did you get it off the top of your head?
Okay, it's a V. Okay, let me write it again. So it's gonna be 4 and 9. Am I right? And then this is gonna be max of 3 and 9. And I already know this value is gonna be 25 plus V of like 3, and 9 minus 6 is gonna be 3. Does it make sense?
Yeah.
So I know V of 3 and 9. 3, 9, I calculate 3, 9. 18. And this is 25 plus what? 3, 3. I know I consider 3, 3 to be 5. So this is 5 plus 5 is 30. That's the reason I put 30 there.
So you just did it in your head?
Yeah, because I knew that this is 5 and this is 5. I knew this is going to be less. I just calculate this one. I knew this is 5. And so got 3, 3 is going to be here. It's going to be 5. 5 plus 5 is 30. I didn't know the others. If I need to calculate, I need to calculate this one. This one was easy because I already have 3, 3. Does it make sense?
Yeah.
I just consider that like really it's okay if I want to steal this one or not. If I steal it, I have this value plus something that I need to steal. So that's the way I calculate actually. So this is gonna be 16. Let's see if we want to keep going. Probably if this is 13. So let's do this one. It's gonna steal. I think this is gonna steal 6, 6, 6 because it's nothing gonna change based on the structure. This is gonna be 12. Probably, yeah, this is 12 and yes, 12, 12, 12. You have 5 of them. 1, 6. Yes, I have. Okay, I think 1, 6 more here. Next one is gonna be 13. And so if this is 13, 13 plus this one is 25. And then this is gonna be 25 again. And then 30th plus 30th is gonna be 26. And this is gonna be 31, actually, yes. 26 plus this one, 31, and then this is gonna be 30, 31, 31, 35. 26, 31. And this is 30. You guys can calculate it again. I just write it here. Just see how. Does it make sense? So this is the way that you guys calculate this one and you write about how the structure of this one works. And then this is the way that we just consider it. So, and then you can write a pseudocode actually based on the structure. This is really, really easy. Everything's going to be the same. But there is one principle in the background of all of them. As you can see, for the one, you do the exact same thing. For this one, you do the exact same thing. You find a formulation that fill the table with that one. So this is coming from the principle of optimality. So we go to principle of optimality that works with both of them. So we talk about So principle of optimality. What does that mean? We define it the way that an optimal problem an optimal problem satisfies principle of optimality if and only if an optimal solution to any non-trivial instance is a combination of sum of its optimal sub-instance solution. What does that mean actually? So it means that, you see, if I go back for coin problem, I look at the previous things that I calculate. It means I look at the sub-problem, sub-instance. It means this solution is optimal if that solution is non-trivial, and then it's combination of the previous optimal solution. It means any previous is optimal, the overall is optimal too. How do we do that? Let's consider coin change. Coin change, you have this one, Cij, which was minimum of what? Ci minus 1 and j, and 1 plus c I j minus di. That's the first one. And then there is another one for the, this is a definition. It means this is optimal. It means if I know that Ci minus and j is already sub-instant, is optimal, overall the minimum is optimal too. It means you can consider sub-problem going forward and calculate. And then we have discrete knapsack that I talk about, which is gonna be, this is gonna be exact same thing. Vij is equal to max of distance, Vi minus 1j, and Vi plus Vi minus 1, j minus wi. So j minus, this is the second one. So this is the example to show that if this one is optimal, the other one is going to be optimal. That's the way that we consider this one. Does anybody have any question up to now? So this is the way that actually dynamic programming problem works. So you guys gonna see this kind of problem in the future too. I'm gonna have in the exam, in the homework, and anything, we are gonna have this kind of problem that you say, okay, find a minimum or maximum these values, and then they are related to solve one of them, and then you will get the result for the other. So that was the this session for today. So as I mentioned, we don't have a class tomorrow, but you guys have 2 hours to submit your quiz. Don't forget the quiz, and then I will submit this one right away. I will submit this class right away, and then I will announce about tomorrow so that we don't have a class, so we'll talk about it later too. So hopefully, and then the homework second, as I mentioned, is already submitted. Does anybody have any question? For the quiz, actually, yes, you need to write a pseudo. You're welcome. So if anybody has any questions, so just feel free to ask. If you don't have a question, I will talk to you guys on Thursday.